not aware.
Good evening, everyone. Welcome to the Central Ohio .NET Developers Group meeting. As you probably already know, this is our meetup page where you can find all the upcoming presentations. We also have a YouTube channel where you can find this presentation and other presentations that we've had in the past. Again, this presentation will be recorded and you can watch it later. As usual, please keep in mind if you are connected to the network to keep it, keep the bandwidth low so that we can do live stream. And any demos that our presenter is going to do are not going to suffer from that. So just a reminder about that. As always, thank you. We really appreciate our sponsor, Improving, for providing us with the great space and where we can meet for this presentation, for this meeting. And our raffle sponsor, Jeffries, as usual, as well. If anyone has ever had one of those prizes, I know that we appreciate that as well. Other user groups in the area, we have the Central Ohio Azure group. They meet every second Monday of the month, 6 p.m. at the Microsoft office. We have the Global App Dev user group. They meet the third Monday of the month at 6 p.m. And we have Columbus.js. They meet every first Wednesday of the month at 6:30 p.m. at the Improvement office over here. And we also have the CBuzz Data, or the Central Ohio Microsoft Data Platform user group. They meet every second Thursday of the month at 6 p.m. at IGS and online as well. And StirTrek is just around the corner. Next Friday, if I recall correctly. I believe there are still tickets on sale in case that you haven't got yours. So hurry up and get your own. Our presenter is actually going to be at StirTrek as well. So get your tickets now. And this is our meeting calendar right now. So today we have Heath Murphy presenting Roll Your Own Home Security with .NET, Raspberry Pi, and Azure. We had a change to our schedule, so as of right now we have an opening for May. So if you know of anyone that would like to present, send them our way, or if you want to present, send them our way. We have talks for June, Coding with Others from a Distance with Mel Grubb. Lightning talks in July. So again, if you want to practice your presentation, or if you know of anyone that would like to practice, Lightning talks is usually a very good starting format. We also have an opening on August, and in September we have an introduction to Blazor for C# devs with Byron Blake, and it looks like we will have Alan in October. If you are looking for work, or are you hiring? Anyone else hiring? Raise your hand. Anyone looking for a job? There you go. So we got both. Yeah, feel free to connect after the presentation, and also next time if you want to bring your resume, and we can help you find a job. And then we can always use the help with the group to get stuff organized, to do this intro presentation, and anything that is involved with getting presenters and whatnot. So if you are interested, just reach out to one of us, and we'll get you set. And that is it. I will turn it over to Heath. Thank you.
All right. Thank you, Sam. Appreciate that. So Sam asked earlier, is this the conference version or is this the user group version? And it could be one. It's a small group. If you have questions, just throw them out there. If you think this is long and drawn out as you want, or short and concise as you want. So given this talk a couple times, multiple conferences. It's actually an oldie, but still a goodie. Hopefully there's some good tidbits here for you. It's a project that's near and dear to me. I still use it today, actually. So it's on my phone, it's on my house, it still runs, operates. breaks daily, of course. There's tweaks, there's bug fixes, but you know, it's not working software. But yeah, hopefully you get something out of this. This is actually my house, so I do have a better lawn. I'm one of those weird guys, big lawn care guy. So this looks like a nice lawn. It's actually like probably a 8 out of 10. Kill it all. I'm that guy.
Is that your next talk? Is the lawn talk?
Probably. Yeah, probably should. All right, so who am I? I'm Heath, director at CGI. We are hiring, by the way. If you've not heard of CGI, the way I explain it, it's probably the largest IT consulting firm you've never heard of. About 95,000 employees global. 250 here in Columbus. We're up in Westerville, have about 250 people, mostly .NET developers. So, being a director means I don't get to code much anymore. That's why it's nights, weekends, things like this that pick my hands. Being from Columbus, living here means I bleed scarlet and gray. So I think it's written in the wall somewhere. OH. Yeah, that was me. That's my COVID hair. I don't know. I know a few of you knew me from like pre-COVID time. I used to rock the long blonde hair, and yeah, that's real. It's not fake. It's not a wig. It's legit, like blonde hair. Cut it all off, and you get a little more professional, right? That's what I was thinking at least. And when you cut blonde hair off, you have to get all of it off, or you're not like rocking like buzz at the end. So I went all the way down. It was. Walked in, our admin at the office is like, had no idea who I was. So I was visiting from another office out of town from Pittsburgh. But I'm sure you have a story too. Here's the story. I have an unhealthy fascination for pumpkin ales. So if you know me, pumpkin ale season actually starts in end of July, beginning of August. You get the good stuff then. By September, October, you're too late. You're not getting the good stuff. You get some of the junky pumpkin ales, but when those are in season, Creeper is my go-to. Double IPA, zero IPA guys, but that's my go-to. That's me. Agenda, a couple things. So we'll actually start with the end. I've got a video here I'll show. Unfortunately, rookie mistake, I didn't bring my Bluetooth speaker, so the video is not very loud. It's going to play on that thing. We'll give it a shot. But we'll start with the video tour of my house, everything I have there. Go into architecture and then jump into hardware and software. Probably spend a lot more time on hardware. I assume most of the room is software junkies. So hardware is probably where it's more interesting and how it's got all wired up. I have pictures throughout the entire thing. So this is actually the control panel. That's a Raspberry Pi stuck in the back of this nice little super duper expensive frame that I bought. That's mounted on the wall that has no touchscreen on it. So let's jump to the video. Yeah, and I didn't update my Bitmoji, so you can see the rocking the blonde hair there. And again, you ought to be really quiet. I've got this thing maxed up. Hey, welcome everyone. I am Heath, and I'm going to take you on a virtual tour of my house. It's going to accompany the talk here, so I've got a lot of things I'm going to show you. Some of them are going to be simulated, so this is going to be just to prove that it's not all smoke and mirrors and that what I actually have works and I am using it. So, welcome to my tour. Oh, that's a narrative as we get through here. First thing, obviously a Buckeye fan. So, I do apologize. It's a little dirty down here. Not terrible. Basically complaining about my dirty basement at this point. And here is the rat's nest. It's a little bit better. I do do some more cleaning up to make it look a little better. It's on my list of to-dos. Take a bunch of wires and shove it in there, and it looks ugly on the outside, but good on the outside. You can see right there, that is the Raspberry Pi. I've got a couple wired up down terminals here. I've got 12 volts there at the bottom that comes in and feeds several electronics. This is a 3.3 volt terminal that is output by the Pi and it's used for a lot of the sensors. The Raspberry Pi is actually there, underneath there. It's on there. And because I have so many wires connected to it, I put it out there so I can pop it off, replace the Raspberry Pi with a blow up one underneath. I've got terminals that I can set right back on top of it. Voltage. So I've got a 3.3 The labels are important. I'll talk about the labels a little bit.
Terminal over here, and then my 12 volt there.
I've got a few other pieces of electronics there that will go in here.
All this big bundle of wires there, I cleaned it up a little bit. It was a rat's mess when I first moved in here.
ADT actually left all this in my house, the prior owner.
A ton of wires there.
Prior
And
owner
then
wanted to get me real into this
makeshift
contract.
wire
You
here.
know,
You see
really, I didn't want to.
orange
I couldn't get out of it.
plug. Funny story about this, which I'll cover on top.
Knowing one day I'd
Across my beam here in the basement. Way
see
over
this
there.
wire going across there?
Like
What I'm
that.
describing here is a power
What we
load.
got going on over here.
Power of a Raspberry Pi. Don't do what I need to do something like this.
There.
Power needs to be a little bit closer to the
Where
Pi
I
than
hooked up the Raspberry Pi for
was
upstairs.
getting enough
control
input
panel.
cables.
Had to run the power all the way over here, and again, I'll tell you a little bit about the story when we get to that area of the top here. But that wire there goes upstairs.
And the Pi actually sits right up in here. Right.
One more thing down here in the
Pretty
basement
convenient
to
to
show
find the
you.
wire in this place.
There is, actually this one right here is one of the smoke detectors that I've got wired up.
Two smoke detectors were left in the house. You saw there were actually
It's
two
where
there.
it should be, down in the
One was
basement.
installed by
So
ADT and the other one came out.
And I've got
So that's one that I've got wired up and
Here.
working. And, other things.
a power cord for camera.
That's another jank job right there. Once you get in these type of projects, you just kind of hack around until you get it all working. Of course, you got issues.
Just to show you what a sensor looks like. Okay, so
That's the magnetic sensor.
that is a magnetic
All the
sensor.
Windows have
So
these.
these are on all the Windows.
Very simple devices. There's a magnet in the top, and the magnet has a switch and it just pulls the lever up and down.
That's the original ADT hardware.
It is. Yeah, they installed all of them.
And here's our living
If you
room.
look at this, the hard part of this is running all those sensors. That part was already done.
Camera.
So that's done. I can't imagine like going into it. I use wireless. Probably
And
not wireless. I think you probably saw my wife running there. She wasn't aware that I was
barely
doing
see it. I've got a better picture here, but there's a little it looks like a little circle.
Hard to see. I've got a better picture, but the way they put the magnetic sensors in the door is a little magnet. They drill a circle. Magnet in the door.
Outside here.
And the wires are on this.
I've got my camera there. That was a speaker.
Can you guess?
Speaker?
It was a speaker.
I didn't know the
I
speaker.
wanted to put a camera out there. I need to get power to the camera. It's Wi-Fi, but I still need to get power to it. And the prior owner had put these speakers out there that just blast. I don't have a big yard, so it's blasting the neighbors across me like thunder. So we took the speaker out and wired it up with a big.
So here it is. This is our control panel. It's
Yeah,
touch screen.
it's the control panel. Here's the front door.
It's exactly like you'd expect a touchscreen to work. So it'll
Looking
go
back,
all
this
fast
like some of
as
the
it
proud
is. And it's
moments.
not all smoke and mirrors.
One of
Let's
them.
open a door.
But UI is mine.
There's the door, goes to my garage.
Door open. And you can see the little red there.
See the red there? Door, one of three
Light
open.
won't show up.
So it's
I've been called out these places.
hooked into it, and garage door opened at 5:17 p.m. So we go ahead and close it. And
You can see how quick it is.
automatic. Didn't have to touch anything, didn't have to
It's
refresh.
not instant, it pulls, but it's near.
Vue.js. And of course, I can arm the system. And that arms the entire system. And right now, apparently,
About this time in the video, I try to fumble with two things and I do all kinds of crazy stuff, so I'm just gonna stop it here
why we're
and
getting
not make you go through that pain.
the warning there.
But hopefully it gives you a little more background into, that it is real. I promise you, and I do use it, and it has been useful from time to time. My 19-year-old son sometimes will just come back randomly to my house. He doesn't live with me full time, and I'll get a buzz on my phone and be there. Of course it is. But okay, so let's move on. Jump into the architecture. So with some of these, I've got an interesting story, and you see this picture up here? Any guesses on where this might be? It's does. Yeah. I got one of those weird houses where they had to build it's an attic, but it's not the top attic. It's like an attic in a loft where they put this, they call it a fireman hidden door, or if you got a fire, a fireman will go in there. I don't know that they ever do that. But. So the story goes, and it's true one, when I was looking at the cameras, when I walk into my front door, the front door is directly below this. So walk in the front door, right there, ADT had a camera. Old from like 2012, so of course I wasn't using that, but they had the wiring there, which I needed 12 volts to power this camera. So I bought this, went out there, and it had other places where the cameras were, and none of that was live, or all the wires were down in the basement. So I go up there and I start twisting wires together, and I go, jolt out of it. I'm like, what the hell is this? Come to find out, yeah, they're like, obviously they couldn't get the power close enough, so they just went up here and just bolted this in, and you can't see it, but the black wire goes right down into it. Things you find when you do this type of stuff. So I used it. It works for me. All right, so let's jump in. I don't know why this is not getting full screen. The taskbar should go away, but there we go. All right, 3 major parts to this. So I am an architect by trade. I've been doing this stuff 22 years, so I think like an architect, which has both good things and bad things. But 3 major parts of this we'll go into. We've got the sensor monitor down at the bottom. Obviously, it's a Raspberry Pi. Its job in life is to sense things. And we've got a lot of things we're sensing down here. So that's what you saw down in the basement in that big grass nest, all connected and wired up. Up here, the control panel. Again, another Raspberry Pi. That's super expensive, nice case with the interface. It does have a small database we'll get to. So the sensor monitor communicates with the control panel. Ultimately, in the cloud, I've got an Azure app service running a mobile app. So that's kind of it in a nutshell. So when we talk about these 3 areas, that's how the communication goes. And then I show you this, and everyone's like, a lot going on here. But we're going to break it down. So same 3 areas. And then over these next few slides, I'll kind of describe my approach, what I took here, how I made it work, and it's been pretty successful at this point. So I think there's some good things and probably some bad things with the design here. But let's jump into it. So starting with the sensor monitor, again, back down in the basement, all wired up at the rat's nest. Each of these pieces owns something. So this owns basically the status of all the sensors. It's completely stateless. There's no database here. There's nothing on that Raspberry Pi I'm storing. No config file read, but nothing that's actually being written to. With all Raspberry Pis, they come out of the box with a GPIO controller. There's .NET Code libraries. We'll jump into the code here at the end that work with the GPIO controller to pull. So I've got, I think, 25 different sensors that I'm reading, set up with a GPIO controller. I've got a process. It wakes up every 2 seconds, goes out and says, what's the world look like? Go through all these sensors, all 25 of them, and is it closed? Is it open? Is it motion detecting? Is it detecting smoke? So it does basically give me the state of the world, take all those every 2 seconds, and then with a SignalR connection, send that up to the control panel. That's all it does. No user interface, it's completely headless, stateless, no persistent. So this I can just throw away the Pi. I want another have backups. So always have backups. For the record here, because those SD cards go bad often. But slap another one in, get this thing up and running, and we're good to go. We're golden. But I do have a story about info plans we'll get into as well. Okay. So you notice here the blue lines are data going up, ultimately to my application. Reds are commands coming down. So with this is the control panel. It sets up there. It has a SQLite database, of course, using any framework good first, because why not? It's .NET, which works well, by the way. So from the sensor monitor hubs, SignalR hub pushes that into the SQLite database and also pushes it out to a separate hub, directly out to the control panel. It's a Vue.js application. I'm a Vue guy. I don't know if you're a React or any other Carl. What's that?
There's a Vue.js license.
No, but now you got me curious.
Super. That's all.
Yeah, nice. Okay. Anyone else? Yeah, I jumped on the Vues, and like everyone else is Angular, and just, yeah. But so the control panel sits out there, and push that out. So if you're going your math here within 2 seconds, that's damn near real time for me. So that's good enough. So the door opens, poof, it shows up there, and you get the little red icon on the control panel. A couple other things here. The control panel itself gets status from sensors, but also is responsible for maintaining the status of what I call the system. So if you think about the sensor monitor down in the basement, I need to keep an eye on that, because that thing, the hard drive will go bad, or the tile will go bad, something will go bad. So I need to keep track of that. That way I can alert and say, okay, something in the system's not working. I also keep track of Wi-Fi status, a few other things. I've got cameras to make sure those are green, those are actually up and operational. You get notified if anything goes down. So that's what I call a system. So every 30 seconds that wakes up and says, what's the lay of the land for systems, and reports that out. Lastly here, as the name implies, it's just a sync process. So every 2 seconds, wake up, look what's in that SQLite database, using SignalR, push that up to the cloud. Any ideas why this might be here? Hey, just go ahead.
Are you logging data?
Why might it be?
You have to look at it later and like something happened.
Probably. I also deleted it so the data doesn't stick around. It's really simple. I want the system to work when I don't have internet. So by storing this locally, basically I can store this. I have all the events. Even though I can't report out and get an alert on my phone, I'm tracking all that data. So eventually, back to visual consistency, this internet connection reconnects. All that data gets synced back up and ultimately gets deleted. So that's the control panel. And then lastly, looking at the cloud dashboard, just a very basic over here, again, Vue.js, because I'm a Vue guy, application. We've got blue lines here. We're coming in through a SignalR connection. The lock means it's public cloud. I've got protection on it. Don't try to hack it. But all the data actually gets stored in the SQL Server. Again, .NET guy, SQL Server, any framework good first, it all fit pretty magically. The cloud dashboard is responsible for all the alerts. So it wakes up, again, every 2 seconds, and says, given the state of everything, am I armed, am I not armed? Should a smoke alarm going off immediately alert someone, or should it not? I would want to be alerted immediately. But if a door opens up and it's not armed, yeah, that's probably my wife or kid there. I don't need to be notified. So its job in life is to wake up, look at the state of the system in the SQL Server, and then just report that out. As well as status and all that. I can look at any door at any point in time and see history of when it was open, why it was open. Do I really need all that data? Probably not, but I'm a data junkie, so why not? So that's it in a nutshell. There are a couple things. The red lines, these are commands I can send down to the hardware. So I can arm the system. I can arm the system in a couple places. I can arm it through the application on my phone right now. And actually, taking this to the next step, this gets into the SES area here. That I have a Home Assistant that automatically arms this thing. So I use Home Assistant in my house to know when my phones, when we're out there in the house, and just automatically alarm it or turn it on. So I can arm it. Those are all pushed back down, and then I can also turn on the siren. So I thought hard about, okay, if the alarm's on and the door's open and I'm not expecting it, do I want this thing to automatically turn on the siren in the house? Has anyone heard of siren? Like a siren? Yeah. It's loud. And I've got a funny story about that. So I decided, we'll just make that manual. I'll turn that on if need be. So that's the system, kind of in a nutshell. Hopefully that was helpful and not too much into the weeds here. Any questions so far?
Yeah, so how
how do you receive alerts on the mobile device then? Is it just through the app?
Through the app, yeah. So it's a PWA.
So it's okay.
So I've got actually built a separate screen in here where I can register out and use PWA, just web alerts.
Okay. But those will work if the app's running, right? Or they work as push notifications if the app's running.
It's background. Yeah, PWA makes it a background work process. So even if the app is not up and running, it's like any other notification you get. It's true watch.
So what's the top calling solution? Do you have one, or do you just?
The call one?
Yeah, so like I have a security service that will dispatch the police if it goes off and I don't respond.
Yeah. That's why ADT, that's why you pay $50 ADT. You have to register that, and you have to, there's a lot of things along with that. So yeah, none of that. So just no fun.
If the alarm is loud enough, your neighbors might call the cops for you.
Right.
Or on you.
Yeah. Okay, so after going through all of that, you're like, wow, that seems super complicated. Why did you do that? Does it make any sense? Well, I work for an IT consulting firm and an architect, so I maximize complexity wherever possible. Yeah. Joking aside, it gives me some benefits. We already talked about the eventual consistency. So when I don't have, when Azure goes down or my app crashes or whatever, I still want that data. So store it and then eventually get that out. You've noticed I use SignalR everywhere, and I think you should too. It's been around for quite a long time. When I first created this talk, probably 2.5, 3 years ago, still have been around a long time, but less people were using it. But now we're like 6, 8 years into SignalR. I still don't see it used enough. If you've not used it before, it's extremely fast, lightweight. Anywhere you use traditional REST API, that could be a case for SignalR. Not all cases, but worked really well for my use case here. One of the other things, I wanted no inbound connections. Now I do have port forwarding set up on my phone for Home Assistant and other things, but I wanted the connection from the control panel to be an outbound connection. You create that WebSocket. Once you've got that created, now you can push down to your house because it's SignalR. It's bidirectional. So that was one of the design considerations and one of the things that you did. Just separate your concerns. So you got bugs. I don't want to deploy everything. So just one thing, fix the bug. I already talked about this. That was a speaker. And this is in the basement. So I found the speaker wire, installed that, installed a wall plate, realized I, made a mistake and had to move it down a little bit. But it's in the basement where no one will ever see it.
Everybody you showed this.
Yeah. Very true. Very true. But yes, of course, in a official licensed electrician did that. Okay, let's jump on the hardware. Hopefully you came for the hardware. This is the interesting part. I think you'll be really surprised when you look at the software that makes this work. It's super simple. It's actually one C# class. And not because I'm one of those lazy guys that just throw everything in one class and it's, you know, it uses onion architecture, but it's just that little. But let's go to the hardware first and then we'll jump into the software. I already talked about this. This is the 12 volts coming in, so positive and negative. Use that for a couple of these devices. And then I've got a 5 volt that powers the 5 that comes in there. And just a random router there, not a router, a switch. That much. Okay. Let's start with what ADT left on. This is after me cleaning up. It was complete rat's nest, just setting up there, all the wires there. They had a label, but the label made no sense to me. It was a tiny ass label, and you know, only about half of them had a label, so it made no sense to me. This is a motion sensor. There's only one in the house. I thought about installing more, but I didn't really need it. But I do have it working. It's wired up as part of the system. Of course, the camera. This one was shocking. And then we already showed talked through the magnetic sensor, and that is the siren. I've zoomed in a little bit. It's actually like this big, but makes noise like this big. Super loud. That's upstairs in my library. So altogether, when you add it all up, 13 magnetic window sensors, door sensors, a motion sensor, very loud alarm siren, a couple smoke detectors, in the right places, one near the HVAC, where it should be, and then another right in the center portion of the house, and then an old camera. It's just worthless. This is the control panel. Again, that hole was not that big. So there was a place there where ADT had a control panel, but it was kind of a smaller hole. In order to get this retrofitted and the Pi stuck in there, I had to put like a 4-GAN box. So if I ever sell this house and move out, then they're gonna have to put gas hole. But it looks nice though. It looks nice from the outside. Okay. Magnetic sensors. We already covered this, but there is actually a better picture. So there it's a little circle is the magnet. So they just drill a little core out and hook it in there. And then there's the switch part of the magnetic sensor with the wires going back. Similar here, there's the switch part, and the magnet then moves up with the window. Very simple devices. Good. So you had to start somewhere. That was the lay of the land. That's what I got. Had to start with the reverse engineering everything that was there. So again, this wasn't easy. I had to take all those wires and say, okay, let's put a ohm meter on it, and let's see. Ohm it out and see where, touch the wire together, touch these wires together, and see what window it goes to. And so we had to do that. I'm down there, here, like checking in. I'm talking to my wife and son. They're going all over the house, closing windows, opening doors to find out, oh, this one here. Put a label on it, and so you can see my little numbers there. Those correlate to an Excel spreadsheet that have the actual. So I know 13 is really the kitchen window back, for instance. Fun task. Not really. But, so button all these things in, getting them all nice, doing reverse engineering. That'll be an exercise if you take a project like this that you ought to take on. Let's jump into some circuits. These are really basic circuits. You're any electrical engineers? Okay, I'm right, you're wrong. Or wait, is it you're right, I'm wrong? If I say anything wrong, so these are really, really simple circuits. But if you're familiar with the Pi, there's a pin out. All these things, GPIO, these are pins that are available to you to use as either input pins or output pins. Really simple to wire up. What we have here, internally, the Raspberry Pi, you feed it 5 volts, it makes 3.3 volts. All of its logic is based on 3.3 and not 5 volts. So when you use one of these GPIO pins, you have to keep that in mind. It needs to be a 3.3 volt logic level. So what I did is, at the end of this line, this switch is basically one of these devices. I ran 3.3 volts to it, and then created a pull-down circuit. Internally, there's a 50K resistor inside. What you'll see some people do is put this resistor on the outside, an external resistor, just so you're not shorting it directly to the ground. You need some kind of load there. I didn't do that, and that was a mistake. I used the internal one, and what happens is this Raspberry Pi sits in the basement, and I've got windows that are all the way up in my son's room, which is probably the furthest spot from it, on the second story all the way in the back. So if you add up like the length of this wire, it seems short on the screen, right? This wire is like 150 feet, maybe even more than that. And you have that big of a wire, and it's coming into a little Raspberry Pi device like this. You get any sort of electrostatic discharge or maybe lightning that's nearby, you blow this resistor. So I do this often. It's probably once every 3 to 6 months, I'll blow the resistor in there. And what I'll do is go look at the C# code, find what GPIO pin I've not used yet, because I've blown quite a bit of them, and then wire it up to that, change the code, and redeploy everything. It works. Although I think with the current Raspberry Pi, I've got, I think, 4 of these things blown, and I'm out of pins. So after this, I got to go buy a new Raspberry Pi.
$7,000.
Yeah.
Are they? I do have one spare. But so yeah, it's super simple. So the sensor is normally closed, meaning the window's closed, that magnet is down, that circuit closed. So I'm getting 3.3 volts there. It's a high. when the window opens, the circuit opens, this becomes a low, I can trigger off that in C# code and then do fun things. Very basic. Okay. Similarly, this is the motion sensor. It's kind of lucky here. I think I was kind of lucky. The motion sensor has 4 wires. 2 of those wires are 12 volts. It needs 12 volts just to power, right? It has electronics in there to do all the motion detecting, the little LED light. So it needs that just to juice it up, which were the 2 terminals you saw in my basement in the box there. And then the rest up here is exactly what we saw before. It's a pull down circuit that I wired up and connected 2 of the wires here, 2 of them there. So in this, fairly fast, it's, I don't know the exact pull frequency, but less than a second. So when I'll get events pretty quick on this when it goes up and down. Okay, now we'll get a little more difficult. Still not super complex, but get just a little more difficult. This, any guess what that is? What's that?
The bell, the siren?
It is. It is. And so if you look at this, you know, why couldn't I use something similar to this to power that? Just a guess. You have a guess?
Stop.
What's that?
Would you alarm the stop, right? It takes too much power.
That's it. Yeah. Yeah, too much power. And home, sort of power. But yeah, so I needed basically 12 volts to power this. So the way this works is stupid simple. You give it 12 volts, it squawks really, really loud. You take 12 volts away, obviously there's nothing powering it, it doesn't do anything at all. Very, very simple device. So I had to feed it 12 volts, but remember, I'm only working with logic that's 3.3 volts on the Raspberry Pi. So this device has been around forever. Anyone heard of a relay chip or an Alto? They make these, you can buy them on Amazon in bulk, it looks exactly like that. The way it works is inside here is a diode, so there's no actual physical connection. It's a switch, it's all this switch, but there's no physical connection between the 3.3 coming in and the 12 volt on the outside. So I can do things like wire this up to a GPIO pin, give it 5 volts just to power this thing, and then trigger it. So it becomes not an input read pin, but an output pin. So I can say, set this pin high, and that'll turn the switch on or off over here. So very simple device. And then over here, I've just got wired up to be a switch. So inside C# code, I can turn it on and off and go through the optic coupler. Then we get to the most complex one. And you'll get to a part in a project where you're like maybe the 80-20 rule, where you're almost there. You get to this last device and you're like, how am I going to do this? Pull my hair out. These are the smoke detectors. I came with 2 smoke detectors, and they were there. I wanted to use them, right? So I did some research. There's 2 wires. That's it. It takes 12 volts. So there's 2 wires going on. There's not 4 wires. I don't get the luxury of having 2 wires that tell me if it's detecting smoke or not detecting smoke. It's just 2 wires. Like, well, how do I wire this up? Because it needs 12 volts. I can't give it 12 volts and then also detect when it's going on or off. So I did some research, and the way ADP does this is there's a special chip board they put in there, and then you plug it in. I got the number. I'm like, okay, so go to eBay, and I find out that this, of course, is from like 2012, and they had one on there. It was used for $250. So 1, there's no guarantee I can get it up and running and working. 2, it immediately broke as from eBay from 2012, and God, it's $250. So I needed to find an alternate route. So I had to be a little creative here. I think most creative is when it's just sitting there, a smoke detector, it's detecting smoke. So there's some kind of electronics in there that's running that's doing the logic of detecting smoke, and there's a little LED. Okay, that's fine. When it's detecting smoke, that thing is making noise, hopefully really loud noise. So my thought is, okay, if it's doing that, I bet it's pulling a lot more juice. And sure enough, it was. Took this, wired it up to 12 volts, put an ohmmeter on it so I could measure the amps that were going through it. When this thing was not squawking, just running, just detecting smoke, it was like 6 milliamps, maybe 7 milliamps per unit. When it's squawking, it's like 30 to 40 milliamps. Order of magnitude is bigger. That's the secret. I needed a way to be able to detect the current going across this, and then any substantial jump in current, it's probably going. It's a good assumption. So how do I do that? It's an ADC circuit chip here. INA 219 is the one I used here. If you look, that's what it looks like. It's not even made for a Raspberry Pi. This is like some bush leaf stuff that I found and I got hooked up here, but it's made for like a featherweight, feather something. I'm not sure to be honest, but it does the job. So give it power, give it ground. It uses I2C interface. So if you're familiar with that, that's a really common interface for hardware communication. .NET library, Vue package, bring it in, solves everything for me. Just a few lines of code. I'll show you how easy it was to get this thing wired up using .NET to be able to detect. And all I do is, again, wake up 2 seconds, every 2 seconds, measure this, and then see, okay, is it 8 to 20 milliamps? Probably nothing's going on. Is it like 50 to 60 milliamps? That's fired. So I've turned it into a binary, true or false. Make sense?
I'm sure you just hit the test button, but I like to imagine that you were holding a lighter up to it.
Yeah, that's the test button, but probably should have been the light. All right, so that's the chip. That's me doing some testing with it. Wasn't actually connected to this Pi. I had a screen on there for very screen. What you'll realize is you try different configuration things, you tear it apart, and you try more configurations, and it's a fun experiment. I've got a separate Pi just for like all my bench Pi, just for playing around with things and breadboard things. Okay, that's the end result, right? Not bad. It's okay. It closes. I've got a little connector there. But works for me. Until I had a leak up there. And the leak was coming in and it dripped down here, took out the 12-volt power supply. Luckily, it didn't take out any of the hardware in there, but I think you have to deal with it. Leak ended up being my fault. It was a pipe that I moved over a little bit. Okay, and I mentioned it once, but I'm really proud of this. Right? I'm not a UI designer, but it kind of looks clean, doesn't it? It's good. It does the job. But yeah, this case was, I think, $150, maybe $200. But it's real metal, so it feels nice. People come over who, they're not technical. They're like, oh, wow, you got that. Yeah, I did. Let's talk about power walls. I told you I'd come back to this. This whole janky running this wire over there. When I had this wire there, again, this is from ADT, they had a control unit head set right there. It wasn't quite as big. I put this big 4-gang hole in there. But so I had 4 wires, and all I need is power to the Raspberry Pi. I don't really need, there's no data here. So this is up here, and then go all the way down, all the way across that beam, way across the basement over here. That's where where you guys saw where the actual wire ended. So it was a long span of wire. So the naive person in me says, okay, I'll take these 2 wires all the way over there, plug it into, it needs 5 volts, plug it into 5 volts. Plug this into the 5 volts on the Pi, done. Thing wouldn't even boot. Wouldn't even start up. It's like, no, not going to happen. I can solve this. Good. I have 4 wires! That means more copper. So took these 4 wires, put them together, put it on there, booted it up. It booted. It came up. If you've ever worked with a Raspberry Pi before in a low voltage environment, a low amp environment, you get what's called the lightning bolt of death. And it's there. You can see it. I'm like, okay, I can see Raspberry Pi. It's booting up, and you get this little bit. And it's warning you. It's like, I'm going to work now. But trust me. I'm going to shut down when you most need it. I'm like, oh, crap. So doing some research, of course, figured out that it's just too long of a distance. I need to move it closer. Moved it all the way over here, put the power unit there, hooked it up. Still tried the 2-wire thing. That wasn't enough. So I had to go all the way 2-wire, this close, and finally got my power situation started. Fun things.
Your wire's like a big resistor.
Yeah. So why Raspberry Pi? C# and Ubuntu. This is from 2.5, 3 years ago. This is my COVID project, by the way. Actually, I'm not running Ubuntu. I started with Ubuntu. Ubuntu had supported .NET Core. It was the first one to have like 64-bit support for it. So I started using it and had it running, and it was fine. Had some weird flaky issues with Ubuntu. It runs really slow. Like if you bring, especially if you bring the user interface on a Pi, they probably got better, I'm sure. But once the Raspbian got support for running .NET on it, .NET Core, I moved there and so I wouldn't recommend it. All right, you guys want to jump into software? The boring part of it. I'll show some code at this as well, so you get to run down what it looks like. All right. Again, being an architect on the .NET side of things, probably back in like 2010, we tried this onion architecture thing, and I have not looked back. So you can see that there. Everything I do, even if it doesn't need to be a full-blown onion architecture, I do it anyway, just because I'm used to it. So it is an onion architecture. If you're not familiar with it, you've got your core business logic. Instead of tiers pointing down, everything points in and can reference the core. So anything outside can point in, not the opposite. Love to geek out on it. But if you look at, so we've got some hardware drivers that just come with Raspberry Pi. Again, it's Ubuntu, but Raspbian is what I'm using now. .NET Core 3.1. It's now .NET Core 6, 7, maybe I updated it. Not every other year I'll go through and do an update of it. But these are the magic right here. So the IoT device bindings and GPIO, that does all the work, all the hard work. The rest of this all is just plumbing. It's based out of the box, that stuff. Any ideas what I mean by this? GPIO Penn State outlives your code. Let me paint the scenario. Imagine you got Visual Studio up. It's a lazy Sunday morning. Your wife downstairs is you're doing whatever wives do. You've got your code up. If you can't code at work, you got to code at home. All excited, and I'm testing this out. I want to make sure the siren is going to be able to work. So I'm in the code to test the siren, and I've got the code up and running. And I warn them, okay, it's going to make a chirp here, right? But it's only going to be for a second. So I ran the code, got up, it chirped, and then the damn thing crashed. I'm like, ah! So stop. I hit stop in the Visual Studio, and it didn't stop. This thing kept going on and on. So once you set a GPIO pin in .NET code, that's not, your code doesn't control that anymore. You've given up control. You've told the Raspberry Pi to set that high. It doesn't unset that thing high. You need to go down, have to run all the way downstairs, into that rat's nest, find that thing, unplug the power. Cat is running everywhere. The dog, I don't even know where the dog is at this point in time. So just words of advice. And control panel stack, very similar. I don't think there's anything revolutionary here. Just I'm a Vue guy, but SignalR. And don't be this guy. What is that? You see that little thing right there? Oh, there's an update. By all means, I'm walking out of the house. Let's click that little install button right there and say, yeah, I want to be protected. It could be a security patch. Yeah, I did that. You could tell this is Ubuntu. So I clicked that one time. It brought the whole damn thing down. And of course, this is when I was like first starting out and was naive and didn't take backups and store them on SD cards. So I lost everything. Now it's just code. I can redeploy code and get that. But what a pain. Word of advice, you're going to run into these weird things and try to take on a project like this yourself. Especially the bleeding edge. I think 3 years ago, this was still kind of new, bleeding edge. You're going to run into this. Okay, the cloud dashboard. Don't think anything really new and interesting here. And it's Azure. It used to be exactly. Anyone not using Azure or the cloud? Anyone still stuck on-prem? Yeah. Still stuck on prem?
Yeah, the nature of our work, you can't.
Yeah.
I'm an AEP where you used to be.
Yeah.
And we're doing SCADA, really sensitive stuff.
Yeah, makes sense. Okay, you guys want to see the demo? Let's just go. I think I promised this like 20 minutes ago. All right. How does that, is that big enough? Can you guys see just fine in the back? Okay.
But can you make the chirp stop?
I'm going to do something here. I'm going to take this and zoom out just a bit. I know you won't be able to read it. And just scroll down. This, I promise you, all the code is in one file. This is it. So when I scroll down and you can kind of see the code here, we're at line 93, 99, 10. We get 135. So if you take all the boilerplate, squiggly lines, all that, all the .NET code that deals with hardware is here. This is it. I don't got it hidden in there, I promise. Stupid simple. Let's walk through a couple things here. So what I've created here is just a dictionary. So these are all my sensors. These numbers relate to the GPIO pin number. So when you communicate with the Pi, you got to say, okay, wire up GPIO pin 5 as a input-output pin. So I just keep it in a basic dictionary here to have that stored. And this is where I need to go when I blow one of these resistors, go back and like, okay, which one? Have I used 18 yet? Have I used? That's this dictionary here. I should put that in a config file. I don't have to deploy. I can just, yeah, I can just change it and not even have to deploy code. Smart. Okay, come down and we've got an initialize method. So the initialize method is fairly simple. It's still readable there. I'll zoom in just one more. You create a GPI controller, which is what you see here, and then for each over all those values that's in that dictionary, and just say open pin and make it a pull down. Remember that circuit I showed you? There was a pull down, a pull up, two different kinds of circuits, whether if it's normally closed or normally open. In this case, what I showed you was I needed a pull down. So I go through that whole collection and just say, okay, open this pin, make it a pull down, done. That's my sensors. Then I go through and I need to turn on the alarm siren as an output pin. Because that siren, remember that's through .NET code, it's an output. I tell it to turn on or off. So I just say, make it an output pin. Problem solved. This right here was probably a lessons learned, but I can't remember my comment here. You ever when you write a comment and you come back to it and you're like, what did I mean there? Default on init, turn it off. Probably old me saying, this thing might squawk, go ahead and just turn it low just in case. We get a little more complicated here, but a lot of this code I found on the NuGet package website or somewhere, and it was copy-paste code. But this is dealing with that INA 219. So this is detecting the current for the smoke detectors. So don't mind some of this ugly code here that does this. It just copy-paste in, set the calibration. Basically, I'm doing the initialization here to get it all redded up so I can read that current value. That's it. So at the end of this, I've got everything initialized, ready to go. Collapse that. I've got a method here called get sensor statuses. So every 2 seconds, wake up, call this, and get back a list of a very simple collection of, okay, what's the state of the world? Here's the date time, is it on or off? Very simple object, a list of objects. And what I do here is go through, in this loop, go through and where's my read method? Right there, GPI controller.read. So given this pin, remember it's a dictionary above, so given this pin, what is it open or is it closed? Is that door open or closed? Is the window open or closed? This read does all the magic for you. You don't have to write any code for that. For motion sensor, a little more difficult, only because I want to change it into something that's more than just open or closed. It's really detecting motion or not detecting motion. So basic translation there to do, detect motion or not. And for the alarm siren, it's an output pin, but I need to know if that thing's actually going off. That way I can squirt it up every 2 seconds and let the control panel know. So I read it just to know, okay, is it actually set high or not set high? And then we get into where the current smoke detector stuff is. And there it is.
So this little method here, recurrent, I didn't write that. That's part of the NuGet package. I initialized it above with the code they told me to put in there. Then I just call this method. Now this was in amps, and I needed milliamps, so basic multiplication there. And then I mentioned, is it greater than 30? It's probably going off. If it's not, okay, then it's off. Simple as that. That's the end of it. A few other methods here, but can you believe that? All that code in such a simple, or all that with such a simple amount of code here. That's why I loved it. All right, so quick, let me demo the app here. So I've got a simulated data text. None of this is obviously connected to my house, but here's where I can play with things and do demos. So I've got the apps running here. And hopefully that is big enough and looks okay for back there. But control panel, mobile device. And with the control panel, you saw a couple things. One thing I learned early on, SignalR is really good at keeping a connection, but showing the status of it is helpful. So this little thing tells me if I actually got a SignalR connection and it's successful. But you can see through here, I connect into some government website to pull in the weather, and that works fine most of the time until it doesn't. But all these, you can see, I've just basically pulled all these so I can see all the windows at any point in time, the date time when they open, and I can arm the system. With the app here, similarly, I can go through and look at all the different sensors, and then click on one, and I've had history in there. This is just dummy data. Nothing's been saved, so there's no history there. I'd see the history of when it was open and closed, and if that was useful. It's never really been useful, but it's fun to do. So a couple things. Let's open a window here. So open the kitchen window. Same code, so this is still using that 2 seconds, and it's going to open a window. As you can see, 2 seconds went really fast because it opened up here. So I can open it up and see, okay, that kitchen window is now open. Similarly over here, I can go to current status, there's a window open, and there it is. Kitchen window opened, and there's the state. Just as you'd expect. But I'm not getting any sort of alert, alarm notifications because this thing's not armed. I don't want to be armed or notified if it's not armed. So let's arm it. You can arm it either on the control panel itself as you're walking out. I thought this would be a great idea. I'll put it right there. As you walk out the door, you just click the button. Simple as that. Do you think my wife ever clicked that damn button? Never. Never. Yeah. Therefore, that's Home Assistant does automate everything. Once you get in this, you realize things you want to automate. And so I'll go ahead and arm it. I'll arm it from the app. Because remember, I can arm it from the control panel or from the app, and they communicate through SignalR. So this is the app. That was really quick. Because this is a command I'm sitting down, it's using SignalR, there's no delay. It's nearly real time. I'm pushing from Azure, well, from my device, mobile device somewhere out here, into Azure, and then pushing it down into my house through that bidirectional connection. And now the system's armed, and it's detecting an alarm status because this window's open. I'm still, this area over here, it's probably hard to see, where it says alert notifications. I'm still not getting one. Any idea?
Because it didn't change?
It's not a technical thing. Think of it as a business requirement.
You had a window open on purpose, you would want
You think about the use case if you're clicking that button and walking out of your house. Front door's open. That's exactly right. That's it. That's it. Yep. That's it. I didn't think that through. I'm like, oh yeah, click that, and then all of a sudden I'm getting, my phone's going off, and I'm like, I haven't even walked out of the door yet. Okay. So yeah, I had to build a delay in there. So you can see it popped over here, and now I can click on it, try to dismiss it, but it's going to show back up again because that's still in an alarm state. So I can unarm it. Now if I unarm it from the control panel, gotta have passcode, right? Because then people can go in and bypass my control alarm system. I don't want that to happen, so you gotta know the super secret passcode. I'd never use this, by the way, but do I still? 0121? Yes, okay. Sometimes I forget that. And course, it unarms the system, and now I can dismiss, and we're good to go. That's essentially it. It's rinse and repeat, basically looking at the statuses, updating the app here, doing push notifications. The push is all through, it's just basic web pushes. So there's a bit of configuration you have to do with the PWA, but it's all basic stuff that with any other PWA app. Any questions on the code?
You said Vue.js for the panel. Is the mobile app also that way?
It is. Yep.
And how do you package that up with Vue.js?
Yeah, good question. So I use the SPA services that are built into .NET. So if you go to the control panel and you go to client app, I do all my code with the Vue, right? You do everything in VS Code. So I do all my development with NPM and VS Code. And when I do a build, I have it build directly to the www root directory. And then this just gets published out. So this is the source code, and this is the built files from the Vue application get deployed. And then because it's using the SPA services, it has, where is it? Hold on. Somewhere in here, I've got it set up to automatically, start up. Yeah, right there. So if it doesn't hit just basic .NET, if it doesn't hit any of the SignalR hubs or any of the controller actions that I have in here, it'll serve up that index.html. Any other questions on the code?
You said you're using WebSockets for an outbound connection from your system so that you're open up reports coming in.
Yep.
How long does that connection last? Does that reestablish SignalR handles that, right?
It does, yeah. I don't know, to be honest. It'll downgrade if your system doesn't support WebSockets. Everything I have does. So it'll create that WebSocket, and the magic just happens underneath the scenes.
And that's in Azure. It's talking to you.
Yeah. Yep. So to create the connection, and then I had to write a lot of defensive code around it just to make sure it's still connected. Probably didn't need to, but I did.
You've got 19 devices, right? And then does that include your siren?
Probably not. I have to
So
count
then
them.
there'd be like minutes you don't use?
Yeah,
Is that right?
I know I'm on my last pen, so I had to use most of them. Now you can wire up things. I haven't done this yet, but you can multiplex them, and I haven't done any of that work yet. And hopefully they're still $50 or $40, whatever they were. I'm just buying new. No, damn it. Yeah.
Why don't you add your signal resistors?
Probably should do that. Yeah. It'd be a bit of an overhaul. I've got so many projects going on, like you guys. You got your own side project. I've got things going on, but that's the right answer. Don't put a Band-Aid on it, just fix it.
You don't even really need a Raspberry Pi. You can get like an ESP32, a little microcontroller those are still $35 or whatever.
And
If you're only pulling them 20 or 2 seconds,
Yeah.
you're probably not taxing the Pi at all, right?
no.
There's also Raspberry Pi, potato. Virtualized Raspberry Pi.
Yeah. I've got options. I know there's lots of we all like to solve problems. We just need time. If anyone wants to do work, I've got plenty of work. All right. Hopefully this is helpful. Yeah. So closing thoughts here. You'll learn a lot, as you can tell. I failed a lot. Use SignalR. I think I've covered that a couple different times. And .NET on Linux with Raspberry Pis are fun. So I really enjoyed the project. It was my COVID project, and I got a lot out of it, I think, and would definitely do it again. Hopefully it's helpful, and you guys enjoyed the talk.
All right, thank you very much once again. Any last questions, folks?
How did you decide on 2 seconds?
You know, I don't know how I thought like 1 second, like seems natural, just do it every second, but I'm like, that might be too much. It's not too much. 1 second would have been fine, but just 2 seemed like a better number. I'm an even guy, not an odd guy. I don't know.
All right. Last chance.
What was it?
Last chance for questions.
Oh.
Given your comments earlier about sometimes resistors blow out or this or that, the other thing happens, you say you're still using it, but is it like reliable enough for maybe the less technical people in your household who are less accommodating when technology doesn't quite work the way it's supposed to?
Seth, do you want to take that? Because we were talking about this before.
The thing that you pay $80 to $50 for so that it just works.
Yeah, there's always something.
Right.
I was joking with Jeff, walking into the house, the cameras, for instance, there's always like, the camera's working, I can go to my app and see it, but when I pull it with HTTP, it's timing out. I'm like, why? Why are you doing that? And then it'll correct itself. So there's always a red camera, you just deal with that. Some of the blown resistors, that's, when you get to this plus add-on Home Assistant with all the rules you build, there's always something that's not quite exactly right. And got LED lights everywhere, and an app for my wife to change the colors of the LEDs into the cabinet, and she's like, it's not working now. Go unplug it, plug it back in, and it works. So I'd say it's not a, you gotta be patient with it.
I got about 1/3 of the way into investigating doing that, and I decided, well, I'll see what ADT says, and lowered my monthly bill to 20. That's all I did.
Nice.
So your motivation can drop from high.
That's worth it, just not get yelled at by your other half.
Somebody else.
All right, so once again, let's give another round of applause. Thank you very much for doing this. It's awesome. All right, we'll get the drawing in just a second.
Those holes are easy to fix too.
What's that?
Those holes are easy to fix too.